Okay, so we're going to talk about cell transport. We first need to go over a couple definitions. The first definition is when we talk about the solute, we're talking about the substance that is being dissolved. So in this case, we could be talking about salt or sugar or some other substance that might be dissolved in the surroundings of the cells. And then we'll talk about the solvent, which is a substance that does the dissolving. So in this case, we'll talk about water. Our first environment is isotonic. Iso means the same, and so you will have equal amounts of solute in the solution and in this case, in reference to the cell. So if the solution has 20% solute, we'll say salt, then it has 80% water. And because this is isotonic, you'll have the same inside the cell. Okay. And then the key question that is often asked is which way will the water move? So in this case, we're talking about osmosis. And we use arrows to represent that. In this case, it is a dynamic equilibrium. And so water will move in and out of the cell at equal rates. The next solution is hypotonic. Hypo means less, and so there will be less solute in the solution in comparison to the cell. So in a hypotonic solution, let's say there's 15% salt. That means there has to be less in the solution than in the cell. The cell may have 25% salt. And you can figure out your water composition based on 100%. So the salt or the water in the solution will be 85%, and 75% inside. So then you have to answer the question, which way will the water move? Water always moves from high to low. So in this case, water will move into the cell at a greater rate than out of the cell. The next one is hypertonic, which means more. You'll have more solute on the outside. So it's basically just opposite of hypo. You have 25% salt and 15% inside. And you can figure out your water values. 75% water, 85% water. Remember, water always moves from high to low, so water will be moving out of the cell at a greater rate than it moves